and welcome to the Learning Enhancement session on Key Stage 4 Chemistry topic, History of the Periodic Table. Before we get started, can you please make sure you have a pen, a pencil, a ruler, a highlighter or another coloured pen or pencil, and your journal with your periodic table in it, or a printed periodic table to hand by your side. So, can you also make sure that you are also in a quiet room with no technology to distract you, so we can focus entirely on this screencast here. Okay, can you pause the video just for 10 seconds, write the learning objective down to understand the history of the periodic table. Okay, so we're going to start off with, as usual, a retrieval practice. Can you pause the video for 4 minutes and answer the 4 questions on here? So pause the video now. So you should have finished there. 4 minutes are up. Can you pick up another coloured pen or pencil, preferably green, and we'll self-assess this now. So, question 1 simply asks, what are the subatomic particles? So there's 3 of them, doesn't give you the number. There are protons, which are positively charged, neutrons, which are neutral, and then electrons as well. Question 2, where are the metals found on the periodic table? On the left-hand side, the left side of the periodic table, the left side there. Question 3, what is special about the elements in group 0 or group 8, right at the end of our right side? These are full outer shell of electrons. They are completely unreactive. So they are completely unreactive because they've got a full outer shell. They are also, you'll get marked for this if you mentioned, they are also all non-metals. And question 4, what charges do subatomic particles have? So protons, neutrons, and electrons. Well, protons have a positive charge. Neutrons are neutral, and that means no charge. And then electrons, which are negatively charged. Okay, so can you give yourself a mark out of 4 there, guys? Green pen, self-assess it. Excellent if you got 4. 3, well done. 2 and 1, let's focus on improvement and understand why we got those wrong. Okay. So what we're going to do for today's learning outcomes, we're going to evaluate other methods of grouping elements, so the history of how the person who created the modern periodic table, Dmitri Mendeleev, came to formulating the periodic table, and why Mendeleev's periodic table is used today, why it's so fantastic and so brilliant and ahead of its time. So, just as a starter, guys, can you list as many scientists as you can that you think were involved in the creation of the periodic table? I have already mentioned 1. Can you think of any more? So just give yourselves just a minute, have a think, and then jot down any other scientists that you might think were involved in the periodic table. Okay, your minute's up there, guys. Just tick off any of these names. Obviously, the most common one is Dmitri Mendeleev, who theorized the most modern periodic table. But another few key ones here are John Newman and John Dalton as well. Those are the two other key ones. But the others we will all focus on throughout this learning enhancement session. So, history of the periodic table. When electrons, protons, and neutrons were discovered early in the 20th century, they were all arranged, the periodic table arranged into atomic number, the number of protons. When this was done, it meant all elements were placed in appropriate groups. So that's how the periodic table was formed today. The early periodic table was problematic, so before that, there were lots of problems with grouping the elements, and we're going to find out why that happened. One key thing Mendeleev did was he left gaps for elements he thought had not been discovered, but he predicted in the future with modern day technology that would be predicted and found today, which has been turned out true. So that's one of the reasons why it's so ahead of its time, and this was over 150 years ago as well, and it's fantastically brilliant and how amazing the periodic table is. So this is Dmitri Mendeleev's original periodic table, where he grouped all the known elements at the time into all 8 groups and to different periods. But then, as you notice by the pink boxes here, they are the unknown ones that he left gaps for, but he predicted their atomic number, which is fantastic and so ahead of its time. And this did take 3 years to do. So, your task, guys, over the next few slides, I want you on a piece of paper or on a Word document or PowerPoint, Can you create a timeline of the history of the periodic table as I'm going through these? So include dates and key points of the following scientists who helped construct and develop the modern periodic table over time. So just like an example here, it starts at 2012, makes its way up to 2017. An example of one there. So, first one, Antoine Levy, 1789. He sorted 33 elements in the periodic table. He believed that light and calorie were elements, and he grouped these elements into gases, metals, non-metals, and earths. Some of the elements were actually oxides because he had not been able to separate them yet. So I'll give you 10 seconds just to jot down the date and the key part there. Okay, going to move on to the next part now. So John Dalton, 1808, so a few years later. Now the key part for him is, first of all, he ordered 36 elements, not 33. But the key part is each element he identified had a symbol. So quite a few were just the letters we know today. But actually a few did have just symbols and lines and so forth and shadings. So they were not easy to memorize as with previous models with simpler ones. But he was the first to do that. So each element represented by a symbol. Therefore, these were one of the very first modern pictorial representations, and they were discarded by another scientist called Berzelius, who formulated a new set of symbols we use today. So, for example, hydrogen is capital H, magnesium capital M and small g, and so forth. Those were created by Berzelius, but they were influenced by John Dalton. He was the main one to have each symbols for each element. Okay, moving on to the next person now. So Dobreiner, 1829. Now he looked at bromine, which was discovered a few years just before that, and so it has similar properties with chlorine and iodine, but was directly in between them. He then theorized that these three elements formed a triad, so all elements formed threes. In particular, he also saw that there were two other triads which could be seen opposite, so lithium, sodium, and potassium, calcium, strontium, and barium. And he looked out for other triads but failed to find them. So he was the first to come up with groupings, and that all elements were in groups of maybe three here. Okay, so pause the video just for a minute and just get down key parts there for your timeline. Okay, moving on to the next one, just a short one. Jean-Baptiste Dumas, 1859 this time. He extended Dobreiner's triad, so three, into families of four. So his table here went off the basis that actually elements were grouped in fours and very similar in families of four. Just jot that down. Okay, Contra, 1863. Now he arranged his list of elements by increasing atomic weights. That's the first key point there. He noticed that there was an increase in atomic weight as he went through the elements. So he ordered them in that way. He did this by wrapping his periodic table around a cylinder to show all the elements line up. And this is the first geometric representation. So this is the first time that the periodic table was shown with symmetry and with the alignment of elements according to their characteristics and presentation. He was the first to do that. So the geometric representation, so what similarities and symmetries each element had with its similar elements as well. Okay, so just jot that down. I'll give you a minute just to pause the video and jot that down there. Okay, moving on to Williamodling, 1864. He was intrigued by atomic weights. He discovered that chemical properties occurred periodically. It's the first key point there. He proposed a repeating unit of 7, and the periodic table of elements had a striking resemblance to Mendeleev's. So this was very similar to Mendeleev's first periodic table that was shown just previously. Okay, so just pause the video there, add in that. Okay, moving on to John Newman's 1864. Now, he took another step and created the law of octaves. So he extended the work of both Dobreiner, who had triads, groups of 3, and Dumas, who had groups of 4. He ordered these groups into laws of octaves, laws, groups of 8. The elements grouped into 8. The known elements were arranged in horizontal rows, 7 elements are wrong, by increasing atomic mass. So he's taken everything that's been used so far and implemented it into his own table, as shown here. And then he stated the 8th element would have similar properties to the first in the series. But after calcium, he failed in predicting a consistent trend. So he started off very well, but then after calcium, he was proven incorrect. So he started well, but then proven incorrect. So we've just paused the video just for a minute, just to get that down. Okay, and finally, and no means least, is onto Mendeleev, 1869 to 1871. So it took 3 years to construct this for him. He listed the known elements in rows or columns in order of atomic weight. So atomic weight. Mendeleev started a new row or column if an element's characteristics were repeated. So elements' characteristics are determined by its elements on the outer shell. So every time the elements repeated, he ordered them in the same group. So that's why group 1 elements all have 1 electron on the outer shell. He also, as it succeeded, he left gaps in his table, which he left for future generations to discover unfound elements at the time, and he was proven correct. These are shown by the pink boxes here, which show the atomic weight, but not known element because he's not been discovered yet. So, pause the video and just get that down, and then that'll be your time and complete there. Okay, so going to move on to a couple of exam questions now. So first one, I want you just to pause the video for 3 minutes and have a go at this question. So pause the video, have a go now. Okay, time is up there, guys. So in green pen or another colored pen and pencil, I'm going to self-assess this. So you should have mentioned that if placed consecutively, then the elements would be in the wrong group or have wrong properties. It would not be in the correct order, and there would be no consistent trend. So that's why he left gaps for future generations to discover and for those future elements to be discovered. So he left gaps because he predicted they would be there. So give yourself a mark out of 2 for that, guys. Okay, and then the second question, guys, I want you to do the same again. It's 3 marks this one, so I'm going to give you 4 minutes for that. So pause video, 4 minutes, go. Okay, so there's 3 marks, guys, so 3 key points. First one being elements must be placed in atomic or proton number order. That's the first key point there, so 1 mark there. Second mark, elements in the same group have the same number of outer electrons. I did mention that earlier. So elements in group 1 will have 1 electron on the outer shell. Elements in group 7 have 7, elements in group 5, and so forth. And then the final point, guys, is any one of these 3. So the number of protons is always the same number of electrons. So they're always the same. Chemical properties depend on the outer electrons. So the properties of each element is dependent on the electrons on the outer shell. So that's why group 1, each group, such as group 1, they all have similar properties and similar characteristics, those elements there, because they all have 1 electron on the outer shell. Such as group 7, they also have 7 electrons on the outer shell, and they all have similar properties. And then the final one, guys, number of shells gives a period. So, for example, if an element has 5 shells, it will be in period 5. If it has 2 shells, like lithium, it will be in period 2 because it has 2 electron shells. Okay, and that concludes the video for this, guys. Hopefully you've learned something new about the periodic table and the history of the periodic table. Have a great day. Thank you.